Very happy to be here at the Diatom Web Academy. So let's go ahead and get started. We're talking about living opals today, diatoms and their kind of legacy in art history. So we'll be doing an art history lens today, talking about how diatoms and the study of them have left an artistic legacy and also have kind of developed the aesthetics of how we present scientific information today. So, as Hira mentioned, I am a microalgae artist. I work with microbes to make my artwork. This is just a jokey way of showing things, but I work with diatoms, desmids, and a lot of green algae and red algae species. I synthesize pigments from different algae to use in my artwork, and I'm a scientific illustrator and a and I do a lot of community participation work. So I do workshops and things that involve the public. As mentioned, I love microorganisms. They're so beautiful. They are our living opals and our algae in glass houses. And I want everyone to love and appreciate them as much as I do. So just too long, didn't read. This is me sampling out at a warm spring in the Lake Mead National Recreation Area. This has the famous brain-eating amoebas in the spring. I wanted to see them. I was very excited about it, so me sampling there. All right, so let's talk about algae in glass houses, our living opals, and all of the lovely ways that we refer to diatoms. So here's just a quote from Charles Darwin, him kind of contemplating diatoms and their beauty in Origin of a Species in one of the later versions. So kind of from the beginning, diatoms have really intrigued people. There's a lot of different reasons for that, but the silica frustules or frustules, depending on how you want to say it, will are really like sculptural pieces. They're really recognizable. It's kind of one of the first things that people were seeing under when microscopy became a hobby. So, and just like as we're covering today, we're going to go through just a little brief history of microscopy as a hobby, and kind of curiosity around microscopes and what you're seeing in microbes, scientific illustration aesthetics, diatomists and their artistic legacy. And I think that's really an important thing to emphasize here. How many diatomists and early phycologists just had like a wonderful artistic legacy that they left with them. My particular interest in the Ehrenberg collection, Dr. Ehrenberg is someone I've studied pretty extensively. And then we'll leave some time for questions and open discussion. I also just want to say that the artwork on this is a lantern style artwork. It's Spooner's illuminations, so you'll see, or transformations. And what this is a an image that you hold up to the light. So when you look at the image, you just see like the woman and the child. But when you hold it up to the light, suddenly you see the microbes. So it's like you're looking through the microscope and you can see all the little cheeky microbes that are imagined here. This is an illustration from 1835 and starts to show kind of the interest in microscopy and understanding what you're seeing. And here we have like a genteel lady and her child kind of looking super horrified at what they're seeing. This is kind of a theme that we'll see over time as the interest in microscopy grows. So, another kind of cheeky illustration here. This is monster soup. So a lot of the kind of early illustrations around this are of the Thames River in London. This was of great interest, and during the Industrial Revolution, microscopy becomes like a hobby, right? So people can now access microscopes. middle and upper class folks can buy them. They're starting to be mass production is starting to be a thing that can be done. So this is becoming kind of a craze and a hobby. So there's scientific discovery and kind of the amateur or the hobbyist microscopist is starting to happen here. So this is an 1828 image. And you're seeing that there's a genteel lady looking in her microscope at water, and she's dropping her teacup in horror because this is all the stuff that's in her teacup. It's in her tea, it's her drinking water. So then you can kind of see the interesting forms here, these sort of imagined monsters that are in the water. So people are really interested in what they're seeing, and they're starting to try to understand the context and really interested in what these organisms are and becoming more aware of things like germ theory and what actually lives in water in this kind of unseen realm. I just want to point out here that you're seeing kind of this round shape. In a lot of early illustrations of this type of artwork, you see this round shape, and I think it's because it reflects the lens of your microscope, and it's starting to give people context of like this is a microscopic image. Prior to this, people didn't really understand what this is. So this is part of kind of the visual vernacular of understanding what a microscopic image looks like. But I just also like her like horrified look of like, oh my gosh, there's so many monsters in my teacup. So this is also part of the kind of hobbyist here is that there are a lot of manuals that are published during this time. And they have like a lot of cheeky illustrations. So you'll see the invisible world. There's like a microbe that kind of looks like maybe it was inspired by a copepod, has a top hat. So you're seeing kind of this idea of like these really kind of cheeky illustrations of what microbes look like, but these really like artistic and fantastical illustrations. So in this particular, this is called The Fairy Tales of Science, and this was an instructional book for children. So this is also part of the hobby. So you'll see that a lot of amateurs or folks who were traditionally trained in art do a lot of work for children. So studying the microscope and studying microorganisms was seen as scientific education for kids, much the same way it is today. But there's just a lot of this kind of these illustrations that have like a fairy tale element to them. Laura Forsberg, and I have a link to her essay, talks about how Victorians kind of treated the microbiome and like the microscopic world as kind of this like real fairyland. So tales of fairies and fantastical beasts were really, really popular at the same time that we were understanding more things about dinosaurs and prehistoric animals, as well as microscopic life. So these are kind of like showing that kind of real life fairy tale where it's like, oh, it's actually the fairyland. And when you look in the microscope, what you're seeing, it's full of fairies. So I just thought that these were really lovely illustrations and kind of reflect the kind of popular conceptions around what you actually see in a microscope. And then this is Mary Ward, and she is a pretty prominent microscopy person of the Victorian era. You can see her posing with her microscope here, which was kind of if you had a microscope hobby, that was a really popular Victorian portraiture. Like you would pose with your microscope. That is something that shows that, oh, I'm educated. And I understand these microscopic images, and it shows part of your personality and hobbies. She had several books that she published. This was again some of the manuals, the popular manuals that were out there. I really like this particular series of images because it shows you how she set up her microscope without a stand and without the use of slides. So you can see that this is light microscopy. She's using a lamp. She has the water in the glass, and she's propped up her microscope on a cushion so that she can angle it correctly. And then you can see, like, again, it has that kind of circle image where you're understanding this is what I'm seeing through the lens of what she says is a tadpole. But you can also see that there's stentors, and it looks like Vorticella in the background with the little kind of spirally necks that they have famously, and some other kind of copepods and rotifers and little floaty organisms back there, some ciliates. So I think that this is a really interesting illustration to show you like how to, as well as just seeing how curious people were about the microbiome and microscopic life. Just as a fun fact, too, Mary Ward tragically died when one of her cousin's steam-powered vehicles hit her, and she's thought to be the first person to have ever died in a motor vehicle accident. So poor Mary. All right, so what we're going to do next is we're going to talk a little bit about the legacy of people who studied microorganisms, specifically diatoms. I think one of the really important things to kind of think about here is that people did not have context around what microorganisms were. So this was all very, very new, and microscopes weren't really accessible to people until maybe the mid 1800s. So a lot of this work is kind of just even building context and understanding around what is in the samples that they're viewing and what it means. So I will kind of start at the beginning and go through, but it's just good to keep in mind that people really didn't have any sort of context around this. And a lot of the early work here is building context and meaning around like um, what is this? What are we even seeing? Because as you know, you kind of saw, this is imagined so fantastically as like a fairyland or full of monsters or full of like chimera, that it's really important to kind of build that context and understand how people were approaching illustration with early microscopes and kind of early exploration. All right, so we're going to start with some of the founders of microscopy, and so we have some examples here of illustrations. So one of the things I think is really striking about these illustrations is that we're starting to build a way of depicting information. So it's kind of thought that the that harmonicas like Kepler's Harmonices Mundi, which would be 1619, and that's going to be the leftmost illustration, is the first book to really use the context of like figures. So you're seeing like figure one, figure two, figure three, or numbering in a lot of these. So that is kind of the first time we're starting to see that. So prior to microscopic investigation, using figures wasn't really very common, or it was pretty inconsistent. So, and a lot of that is because like medieval bestiaries and things like that, or medical texts, either had illustrations that were formatted in a very different way, or they dealt with things that you could visually see. So, for example, you might have like a wolf and a lion and an elephant in your bestiary, but you can see those things. So there wasn't really a need for that kind of labeling of figures. This starts to happen more when there's categorization, when we start to kind of put more of the modern scientific organization on things. And it also really rises up with this kind of aesthetic with microscopic life. So you're seeing animalcules on the right side. This is a later illustration of, this is based on Leeuwenhoek's original illustrations. It was redone by another artist. This is kind of a later plate, 1795, but it's based on earlier illustrations in the 1600s. So, but you're starting to see kind of this idea that we can't see these up close, or we wouldn't be able to tell the difference with our naked eye. So we actually need to label these and then reference some sort of table. So this is actually the drawing of microscopic life starts to emerge with this idea of that there are figures and labels and things and like cross references. This is extremely common today. This is how most scientific illustration, especially when you're showing multiple organisms, is done. But it's just really interesting to see this emerge so early and to start to see the idea that, you're using figures and to actually refer to various organisms. So I wanted to also bring the very first illustration of a diatom, 1703, now attributed to Charles King. This was anonymous for a while, but recent research found out who actually made this illustration. So what you're seeing is you're seeing the Philosophical Transactions of the Royal Society of London. So this has a lot of different kind of illustrations here. We've got illustrations of sunspots. We've got some illustrations of, it looks like some other aquatic plants. And then we've got our illustration of our diatom here. So this is the first known illustration of one, and you can see that they're already using figures to refer to things. So again, things that you might not be able to see with your naked eye, like sunspots. Um, but I wanted to show you all that as early as 1703, diatoms specifically were being illustrated and shown in context. So, and this is pretty recognizable, obviously done with a ruler here. All right, so we're skipping ahead a little bit. I was trying to find some intermediary illustrations, but they're a little hard to find. Illustration work and publishing prints and publishing, illustrations of any kind was extremely expensive. So there are fewer examples of that up until the 1800s. So this is Justine Giraud-Chantrante. I think you would probably say it that way. Or I would, beg everyone's forgiveness for this. And what we're seeing here is that he studied largely macroalgae, but but illustrations here show specifically animalcules. So you saw that on a previous slide as well. So thinking like early scientists considered diatoms to be animals because they moved. It was thought plants don't move, animals move. So you'll see the term animalcule or infusoria later. Those were really common terms used throughout kind of the early history of diatom study. Um, so you'll see like in this illustration here again, using figures, these seem kind of out of context and they're obviously not to scale to each other and they lack a lot of detail. So we're seeing that the optics and the quality of microscope images that we're getting are still pretty don't provide a lot of detail. So they're less sophisticated than we have now. But you can see that there are some things in here that could be diatoms. He describes these as animalcules, and uh, you can kind of see the different organisms here. There's also some cyanobacteria, some chain-forming green algae that we can see. So you're starting to see this kind of lacks more detail, but you're seeing that, that labeling of figures and things that are starting to be diatoms. All right. So, and now we have actual diatoms here, very, very recognizables. So Friedrich Kutzing, again, forgiveness for all of the name pronunciations I butcher today. Um, so this is a Symposius Diatomarium. So, and it has a much longer name. A lot of these books and publications have very long names that don't exactly roll off the tongue. But you can see that there are a lot of very recognizable diatoms in here. So this, like, Kutzing was one of the uh, scientists who put desmids and diatoms into separate families. So he kind of differentiated them between the two. Although what you'll see is, especially in kind of the artwork and the information put out to the public, desmids and diatoms are often kind of conflated, or they're drawn together because they have very similar forms. But he actually was one of the first folks to split them apart. And you can see he has like this amazing artwork of various diatoms. And what I really like about this is that he shows them at different magnifications. So you'll see like a smaller illustration and then a larger detailed illustration. And I think that that's really pretty fun. And it shows that he's kind of he's trying to build that context of like, these are really small and this is a detail. So still kind of building up that artistic sense of like, this is small, this is what I'm looking at, and this is the actual scale of the organism. I really just like these two. This is kind of an early use of a grid. You can see each organism kind of has its own box, which I think is quite sophisticated for the time. Because as you'll see, a lot of later illustrators, that wasn't really a thing until later kind of illustrations. And so this is another early phycologist, Dr. Jacob Bailey. He was a graduate of West Point and was an army surgeon. And a lot of the early samples from the United States came from Bailey and were distributed globally, all around the world, to various scientists studying microorganisms. So you can see his field notes here. There's a Sororella, pretty recognizable. It's kind of vague. And then you will see his illustrations from the the report of the expedition of the Rocky Mountains, from it's one of the John Fremont expeditions. So you can see these specifically are microorganisms from around the Columbia River in Oregon, very recognizable cymbellas. But you can see again, this is like the illustrations are getting more detailed at this point, so you can see that there's more detail, but they're not quite right yet, right? So he is still pretty early on in diatom discovery, but he's a very important person because a lot of kind of the base samples and the species types we have for North American diatoms come from him or his connections to various scientific expeditions. So it's just it's a good person to keep in mind. There's constant references to him in other works. Okay, and so this is Dr. Ehrenberg, probably one of the big names in diatom science. And this is a collection that I have studied pretty extensively. And we'll talk a little bit more about my artwork and study of it later. But this is one of his, some plates from his kind of masterwork, microgeology. And you can see that these have like very, very dense compositions, right? So things have a lot of information in them. They have a lot of microorganisms. Um, we are again seeing that kind of round shape there. So I think Dr. Ehrenberg is showing showing scale as well as kind of the density of the sample. So you can really see that we're still using that kind of round shape. So he's like, this is what it looks like in the lens within context, and really packing the information in there. So you're seeing a lot of organisms. This is very visually dense work. Um, What's interesting to me about this is that these are organized by place. So we have he it was responsible for a lot of categorization of diatoms early on, but these are kind of showing more of a sense of like where things are found, rather than taking things out by shape or species that happen later. And then this is just a close up. So you can really see that like that level of density of the particular organism. So you're seeing that round shape. So you're showing people the context of like, okay, this is what you see when you look down the microscope into the lens, but you're seeing that kind of like a lot of organisms in there. It's kind of almost visually overwhelming. I wanted to bring in Agnes Catlow. She's one of my favorite illustrators here. She did a famous work, Drops of Water, again, another instructional manual for children. Um, but I think her work is really beautiful, and I wanted to add some folks who might not necessarily be the big names, folks who were amateurs or who were working in their own capacity. You'll have to remember that phycology and the study of diatoms was a brand new thing, and this was like a developing practice. So you can see that there are a lot of people working as artists who have an interest in diatoms or were in another practice altogether and just had an interest in diatoms. But you can see here that both diatoms and desmids are included here. And she has a really kind of beautiful, elegant drop of water again in kind of that lens uh, context there. So really beautiful work. And you can also see like how this was treated. This is a really lavishly decorated book. That's the cover. It's got gold leaf and color illustrations, which would have been extremely expensive at the time. So this was really like a hobby for folks who were valued their education, had money, and were curious about the world. I highly recommend checking out her work, Drops of Water, though. She has other illustrations that are just lovely, and her text is pretty charming as well. All right, so this is Arthur Hill Hassel. He's not necessarily someone who studied diatoms, but I did want to show kind of more along show more examples of kind of that, using that circle to build context. So this is 1850, and this is again Thames water. This is kind of a ongoing theme. Microscopy was very popular in Victorian England, and people, of course, lots of folks in London had access to the equipment. So people were looking at their water sources. Um, Dr. Hassel was a advocate for like public works and health and well-being, and really wanted to push for better water quality for the city. So here he has beautiful illustrations of various microorganisms that you find in the water. So you can see all kinds of things, nematodes, you can see Spirogyra there, we've got Fragillaria, Sororella. Yeah, so we've got like a lot of different things in here. And of course, like, Paramecia and all those gnarly things. So this was really, this illustration was extremely popular and really made the case for making public waterworks available. So it was these kinds of things that, like, giving the context is what you're seeing is in your water. No, you can't see it with your eyes, but it's in there and it could be making you sick, was a really important thing, and really kind of pushed that exploration from the common person to look at microorganisms. I also think these illustrations are just so beautiful. They have everything in there, and the whole point is to say, like, look at all this stuff in the water, but it just has this beautiful richness of organisms. It really shows you how much life is in water. And you can see that this is there's kind of a comparison here. So I took some of his I took Dr. Hassel's illustration and put it right next to the wonders of London of a London water drop from Punch magazine, which was a satirical magazine. You can see there's water. There's kind of the monsters again, right? The fairyland that have an inspiration from like water fleas, copepods. They're very gnarly. One of them is kind of conveniently carrying a coffin, indicating that this is making you sick. And there's a skull and crossbones in there too. So, all kinds of like horrible things. So you can kind of see how similar the compositions are here and how this is again kind of telling people, even though you can't see this, these exist in your water and they're doing you harm. So very important artwork for the advocacy of public health. So we're looking at 1861 here, Andrew Pritchard's work. Really, really beautiful color plate here. So another very kind of lavish work. So Andrew Pritchard originally trained under his cousin, who was an artist, and his brother was also a watercolorist. He had a publication. This is from the History of Infusoria, including desmids and diatoms, British and foreign. And you can see that this is starting to have more of a modern sensibility around it. So these illustrations have a lot of detail, first of all. You can see that there's more detail than in previous illustrations. Optics are getting better, but you're still seeing a lot of density. These are very, very dense illustrations. They're not really categorized out by, they're not put in their own squares or boxes. In particular, the one on the left, the illustration on the left, there's a lot of overlap. So he's kind of showing comparative size, but it's really difficult to kind of visually parse all this stuff. There's just so much. And these organisms don't necessarily relate to each other as far as like, categorization. So you can see that this is still kind of a mix. This is, I would consider a transitional illustration. It has the figures and it has the style, but of kind of the older illustrations. It still has an overlap, but we're seeing a lot more detail. Highly recommend checking out his book as well. And of course, we have to include Mueller in here, kind of famous diatom arranger. He was classically trained as an artist, and we're seeing that, diatoms really becoming art. This is the living opal part of this, where each one of these is a jewel, and his arranged slides are a jewel box. So this becomes a really popular art form that various individuals did during the Victorian era. So also kind of later artists, Klaus Kemp, I believe is his name, was someone practicing this in the 20th century. People were very cagey about how they made these, so a lot of the techniques were kind of obscure or lost for a while. But just seeing kind of the artistic practice, so diatoms as a whole entire artistic medium, just the way that watercolor or oil paint would be. These are extremely beautiful. There's extensive pictures of them online. Highly recommend checking them out. They're very sought after even to this day. I also wanted to give a shout out to our early photographers. So John Redmayne, photographer, this is an absolutely beautiful Cimbella from 1877. So what a absolute masterwork. He had a self-published book, Micro Photographs from the Diatomaceae, and there's a copy that recently was auctioned at Christie's, so you can see some images there. I also include a link to a website in my references where you can see more of the images, but really recognizable Cimbella here. Absolutely stunned by this being 1877. So you can see that very early on, people who are studying diatoms were wanting to photograph them to get more information. So I think that this is just an amazing thing to see. All right, and we've got Henri Van Heerijk. And I wanted to include this too because again, we're starting to see a transition in the artistic style. You can see that he was also including photographs. So you actually have on the rightmost plate some photography of diatoms, some close-ups of the actual diatoms themselves. He was a very early adopter of photography. He was an early adopter of electricity. He was one of the first people to have electricity put in his home. And you can see that this is starting to have that kind of more formalized look of the of how we kind of expect scientific illustration. So, organisms starting to be more categorized by their type, lots and lots of detail, more space in between, so you can more visually parse them. So, really beautiful work here as well. Adolf Schmidt, another kind of really important person in this space, and he created this really stunning atlas der Diatomischen Kunde, so kinds of diatoms, the atlas of the kinds of diatoms, essentially. And he collaborated with several other scientists, but these illustrations are just so clean, so beautiful, extremely detailed. We're still seeing some visual density, but there's a real sense of aesthetics here as well. So just showing the beauty in the form of diatoms, tons and tons of detail. So his work really was published into the 50s and, with various updates, but just seeing this absolutely stunning looking set of illustrations and really starting to see the more modern style. Francis Wohl, he was an interesting person. He was actually a Moravian priest first and a diatomist as well. But he published Diatoms of North America, illustrated with 2,300 figures from the author's drawings and 112 plates. So you can see that there's like a lot of illustration in his work. We're still seeing some overlap here that kind of calls back to the earlier diatom illustrations, but these again are starting to be categorized more by type. Lots and lots of detail here. These are extremely visually detailed, and they're starting to have a more consistent form. So again, kind of looking more towards the modern style of how we depict diatoms and diatom illustration. And then we have to include Haeckel here. Very recognizable. His Art Forms in Nature is kind of one of the big important works about a scientific depiction. We've got a whole kind of array of microorganisms here, including lots and lots of diatoms. Incredible detail here, and really like focus on the aesthetic. So we start to see kind of an aesthetic approach to these scientific visualizations. Haeckel's really important. He heavily influenced the Art Nouveau movement. You can really see it with kind of the symmetrical forms that you're seeing here. But interesting approach, not necessarily the more formalized, scientific practice of that, but you're seeing that kind of again like diatoms as a medium, as an art form unto themselves. And then Friedrich Hustet, who is another very important person in the scientific world. I believe last year the collection was featured in the Diatom Academy. Be sure to check it out. But this is kind of our final illustration of the series, and you can see that this has a lot of the modern vernacular of how we approach scientific illustration of microorganisms. We've got labeled figures, we've got things grouped by more by category, we've got no overlap, so things have enough visual parsing and difference in order to see individual organisms without confusion. Lots and lots of detail. So we're starting to see a lot more of that. And this is kind of like the aesthetic that we kind of have today. Granted, we're using color photography and scanning electron microscope images, but this is kind of like the end of the Victorian era, the transition into kind of our modern practices of art history and how we depict microorganisms. So I'm going to talk a little bit about my artwork, just my interest in this. I particularly followed the Ehrenberg collection, particularly Dr. Ehrenberg's illustrations. And what I've been doing is I have been pinpointing where the original samples were taken by the various scientific expeditions. I've been revisiting those locations if they still exist, retaking samples, and then making artworks that are based aesthetically on Dr. Ehrenberg's work. So, I'm not the only one. You can see, for example, in Wohl's work, figures 11 and 12 are directly, they are referenced as Ehrenberg's illustrations. You can see that there are both of those illustrations in the samples from Oregon. So you can see that he directly referenced Ehrenberg's images to make his own images, which I thought was really interesting. So I'm just going to give you a couple examples. So looking at Ehrenberg's illustrations of the various microorganisms, tracking down things to the American River, resampling in those areas. Another thing, the Columbia River. So these are Columbia River illustrations. We've seen this a couple of times. So just looking at the organisms, and you can see Ehrenberg's drawings have like not as much detail, but again, using that kind of aesthetic of the round to represent the lens, and some overlap with the organisms as well, and kind of that, like, I would say, like maybe medium fidelity level of detail for what the internal workings of the diatom look like. And then here is me at the actual Ehrenberg collection at the Museum of Natural History in Berlin. So I have my artwork on the left and Ehrenberg's original artwork of the Deschutes River on the right. I was honored to be able to visit the collection, and I also have written and submitted all of my research around where the collection sample sites were, who collected them, and what days. And that is now a part of the Ehrenberg collection to give further context to the the collection itself, where it came from, where did these microorganisms come from. And just another one too. So you can see kind of like that is the actual physical piece of the organ illustration, and that round piece there too. So you're seeing kind of like very much that kind of mid-Victorian aesthetic before we had really gotten our visual aesthetics together that we now do today. And this is a recent poster I did of the Columbia River. I've been studying the Columbia River a lot since that is close to me here in Seattle, close enough at least. And again, using that kind of older scientific art approach, so that Victorian art approach where things overlap each other. The figures are numbered and there's a reference later. There's kind of that medium level of detail for the internal workings of the organism, using that round lens shape to give folks context about scale and size and things like that. I will end there, but my call to action is that many of you work in academic spaces or you have partners with that. Please digitize your collections. I was able to get all these wonderful artworks because they're digitized, and there are many more that should be digitized, could be digitized, that could inspire us and teach us a lot about how we developed artwork over time and also honor the legacy and honor the incredible amount of artistic work that early diatomists did and gave to us. Just as they have a scientific legacy, they have an artistic legacy that is really important to all of us and can teach us a lot about how we talk about science, how we visually understand things, and how they worked and what they saw. Yeah, that is kind of the end of my presentation.
Well, thanks, Shelly. That was great. What a interesting timeline to just to go through and think about. We actually had to invent a microscope before we could see any of that stuff. So anyway, um, we got some time for questions before the top of the hour, folks. You can type your question in the chat, or we've got about looks like we got 24, 25 folks online. If you feel like raising your hand, you can do that as well. I see Gina, you've already raised your hand. Why don't you go ahead and ask your question, Gina? And you can even unmute and unvideo or
I'll
revideo, whatever.
I'll unmute. So this is an awesome presentation, Shelly. Thank you so much for bringing this to us. You mentioned early on something about extracting pigments from algae. So in the diatom works, your diatom works that you showed us, did you use those pigments or was that watercolor?
It was both. So I use a combination of the algae extracted pigments. I also try to use earth pigments or charcoal from forest fires that are in the area, or earth pigments that are near the sample site. So lots of ochres and iron oxides. Unfortunately, the algae extracted colors are not super light fast. So I tend to use a combination of both in order to make the works. I have an algae farm immediately off camera here. I'm growing Hematococcus, spirulina, and Dunaliella salina, and all of those organisms I use specifically for pigment. So I turn them into watercolor, but they're not really, unfortunately, I keep them in the dark, but they're they oxidize really readily. Those are images of the artworks that I made a couple years ago. They've actually changed color over time, so they aren't even the same as they were.
Really cool. Thank you.
Thanks, thanks, Shelley. I've got a question in the chat from Elena. How were the illustrations in the 1800s created? Um, I mean, we look like we saw Ehrenberg's like pencil pen drawings, but how are they converted into, be able to be printed and produced like that?
There's a lot of uncredited and unsung lithographers involved, right? So almost all of the things that you're seeing, a lot of the illustrations I showed today are in book publications, and those would have been made into a lithograph, or very occasionally, like very early on, possibly like a cut of some kind, like a woodcut. That's pretty rare though. Yeah, I think that, but the original ones are going to be pencil or pen. Ehrenberg's illustrations were largely pencil and pen. He did watercolor some of the images too, but almost all of them, are going to be a lithograph of some kind. And unfortunately, those lithograph artists are often uncredited. I wasn't able to find a lot of information about it.
Yeah. One question that I have, Shelley, since you got to go to the Ehrenberg collection and I have never been there, when we look at Ehrenberg's images or his images, and he uses this circular, format, and what I'm curious is he actually illustrating exactly what he's seeing in a circle on the microscope, or is he taking some liberties?
I think that, that is hard to tell, right? I think that there's probably some liberties taken, right?
Mm.
I do think that some of it was probably an economic choice, to be honest. Publishing a illustrated manual in microgeology is several hundred pages, right? So that would have been a very, very expensive book to print. So I actually think that he kind of crammed it all into as much as possible. And you can kind of see that kind of I think that that's also why some of the earlier aesthetic is the way it is. They wanted to get as many organisms in each illustrated plate as possible. So I think that there are some artistic liberties done with that as well. Ehrenberg also was very married to his early microscope. So I think kind of the lack of detail for a lot of things were because he kind of refused to upgrade his technology. So even at the end of his life, he was using like a 1830s, 1840s microscope. So I think that that has a lot to do with like the level of fidelity of his work as well.
Um, we've got just another question in the chat, and whether some of your prints or your work are actually available for for sale.
You can contact me about it. I don't have any sort of, my information is like available online and you can contact me. I don't really have a storefront or anything. This is somewhat of a niche um, sci study. I do have some prints, but I have like a lot of postcards. So I love a postcard and a souvenir. So I do have a postcard series. So yeah.
Cool. I have one sort of follow-up question. So as we've, seen the development towards more of the sort of classical scientific illustration things, one of the key things that has been always pushed is scale or scale bars or even scale. Like I know that like Schmidt's Atlas is published at 900x, and so you have to almost have an original copy of it to understand what 900x means. There's no scale bar on the images. When did that start? It looked like a lot of your earliest images, were not scaled, or that they weren't. Did you get a sense of when that was happening?
I would say that so yeah, there's kind of like I kind of stopped at the kind of very late Victorian, early Edwardian era.
Hmm.
Um, but I think like it seems like in the 30s and 40s when photography started to happen, that's when there were scale bars and things that started to happen, right? So when illustration became less popular and photography became more popular, I think that in early, quite frankly, early artists and early diatomists really just focused on communicating what was not able to be described by words, right? So when you think about like what does a Pignol aria look like? How could you even tell somebody that, right? Like, so I think that they really had a different emphasis in mind, and that scale was all kind of relative. They also probably didn't quite accurately understand the scale. So I think that kind of more came into like when there was electronic measurement available.
Sure, sure. Hira, you've got a question.
Yes. First, I just want to thank you, Shelly. It was such an amazing presentation. I think my mind is blown. Um, so I just had like a curious question, like what made you interested in diatoms? Like if you could like just share about your journey a little bit, like how did you came across them? I know you are an artist, so probably had some leaning towards it, but like how, like what made you sort of like jump into that diatom field?
Yeah, so I kind of accidentally became a microscope artist. My friend was moving and she gave me all her microscopes and was like, "Hey, hold on to these while I move." And I of course started with human samples. I think we all kind of start with ourselves. I was looking at skin and skin cells and cheek swabs, but honestly, they're so boring. We're all the same. Like a cheek cell is a cheek cell is a cheek cell unless it's cancerous or something, then that's bad. So I took a sample from this horrible puddle. I lived in Chinatown in downtown Seattle, and there was this permanent puddle in front of a dumpster behind my building, and I took a sample, and I just fell in love with what I saw. I was like, now this is interesting. And then while I was researching, because I had no idea what I was looking at, I kept seeing after Ehrenberg. I just kept seeing Ehrenberg, Ehrenberg, Ehrenberg over and over. And then they had their entire digitized collection online. So I was able to see all of his illustrated artwork. And diatoms not only are beautiful, they're sculptures, right? They're also persistent. So that's how we have them as part of the fossil records. So they're also really durable. So it was something where I was able to find them. And then if I had to carry a sample back, a lot of the green algae and cyanobacteria die in transit, but the diatoms were still there and honestly still kicking strong. So it was something where I could always see the diatoms. And then I fell even more in love with them because they're beautiful sculptures. They move, but they're not motile. Like there's all these amazing things. So, yeah.
Cool.
Okay,
We're
thank
we're
you.
com we're coming up to the top of the hour. Sarah, why don't you finish up with your last question and close us out?
Okay, thank you. Thank you, Shelly, for a really terrific talk. This is, interesting artistically and scientifically. And I'm super interested in the contributions that you made to the Ehrenberg collection of resampling the sites of his works. You said you gave that to the Ehrenberg collection. Is that available online, or how can we find out about your scientific contributions here of resampling the Ehrenberg um, type materials?
Yeah, I have the document. The document is in the Ehrenberg collection, so if you do go to it in Berlin, you can see it. But I have the document. I keep it as a living document. More and more things are digitized, and as I learn more, I do update it. So I have like it's V1. I'm probably going to put a V2 out this year as well. But I'm happy to share it. And it's just an extensive paper of like who took the samples, where was the information, some corrections to the database that they maintain as well, some historical images and pictures. And it's full of reference material of kind of the original references of place names and things. So I'm happy to share that if you want to read it. It also is with the collection, but it's something that like I'm very excited about, and I'm hoping that in the future I can also visit the Bailey collection, which is at Harvard, which is not digitized, and I would love to see what Dr. Marcus Bailey, or I'm sorry, Jacob Bailey, has to share with us. So
Yeah, it's a fantastic resource that should be available to everyone. So yeah, I'd be really interested to see it and love to see you publish it in some way.
yeah,
Thanks
absolutely.
again for a terrific seminar.
Excellent. Well, my fellow algae pals, thank you so much for being here today, and hope to see you all during the Web Academy this year.